Thank you for joining us. In today's webinar, we'll be sharing tips on how to build a business case for optimization. Now I'd like to introduce you to our two presenters today. Our first presenter is Dr. Russell Halper. Dr. Halper has devoted his career to delivering cutting-edge analytic solutions to problems in the supply chain, manufacturing, revenue management, and other application spaces. Russell is an expert in developing optimization-based solutions for problems in a wide range of spaces as well as across a wide range of industries. Russell holds a PhD in applied mathematics from the University of Maryland in College Park. Our second presenter today is Dr. Colin Kessinger. Dr. Kessinger has a solid track record as a supply chain innovator and counselor to senior management, manufacturing, and marketing executives. Colin has focused on applying quantitative techniques to a range of areas, including risk management, supply chain flexibility, capacity planning, and strategic contract design. Colin has consulted extensively in the capital equipment, high technology, electronics, telecommunications, office equipment, baked goods, and automotive sectors, and he holds a PhD in industrial engineering and engineering management from Stanford University.
Thank you, Chris. Thank you all for joining today. Today's topic is on building a business case for optimization. And being in the consulting world, this is something that we frequently run into. Our goal with this talk is to equip you with arguments that you can use within your own organizations to help overcome some of the hurdles that one runs into when trying to implement optimization-based solutions. At its basic level, it's difficult to sometimes simply describe what optimization is. If you could describe to the business user what optimization is, it's sometimes hard to understand what the applications for optimization are. Indeed, when we looked at many of the comments that we got back from folks as they signed up for the webinar, this is one of the key things that we heard. Beyond that, there's this rather simplistically held view that optimization is something where you simply push a button and you either get a least cost or maximal revenue solution to an answer, or perhaps something different if you're using a different type of objective function, but you push a button and it returns an answer. And well, it does do that, and that is one of the values that it brings. It's actually a much more powerful tool than that, and its uses are much more nuanced. So for our talk today, we'll first talk a little bit about the value of optimization in practice. We will then talk about some case studies from real-world examples that we've worked on. Then we will talk about building the business case for optimization beyond simply looking at cost savings. I will use the word cost savings in this talk as a term, but you could simply in your mind replace that with revenue maximization or the appropriate other objective function in optimization, should you be thinking about other problems. And then we'll leave you with some closing thoughts. But before we get into all of that, let us tell you a little bit about ourselves. We're with a firm named End-to-End Analytics. We've been around for 11 years. And our mission is to drive the adoption of analytics. We work across a variety of industries and across a variety of problems. Much of our work is in the area of network design, inventory planning, scheduling, other aspects of supply chain planning, forecasting, trade promotions management, and pricing. And we work with companies of all sizes, but we've been fortunate to work with industry leaders across a variety of sectors. And these are the type of companies that have the ability to go and pick any solution they want, and they often come to us to help them develop the right solution for them. And of course, some of those situations involve optimization. Just so we can all level set, most of us in the call have seen what an optimization model is before, but I want to cover it and how it relates to building a business case. An optimization model essentially consists of three parts. There's an objective function, and you can think of the objective function as what are you trying to accomplish? Are we trying to minimize transportation costs? Are we trying to maximize revenue? Are we trying to penalize bad behavior? You certainly could come up with a variety of other objective functions that may come into play depending on what scenario you're looking at, but you could really think of this is our goal. The decision variables in an optimization model, those really are the levers that we can pull to achieve that objective. So, what things can I influence in my organization and do I have control over to change that are going to help me move towards that goal? And finally, you have the set of constraints. And the constraints you could think of are the things that you must adhere to make sure that the results of the optimization model can be implemented within an organization. So oftentimes when we have conversations with clients around how do we build an optimization model, one of the things that we do is we try to relate each piece of this optimization model to those different pieces of the business process. And we find that that's a very effective way to have the conversation with them and make sure that they understand how the model is in reality giving them the answer that they need to be able to run their business and that they could trust its results. So now that we've talked a little bit about the structure of an optimization model, this is still a fairly abstract structure. And we get asked fairly frequently, well, where can I use optimization? And there are many, many uses for optimization, and it's hard to give one rule which is going to cover all of them. But when we think about where we can use optimization, we generally look at two different criteria. And if you are in the right place on these two criteria, there's generally a pretty good chance that you can use it to solve your problem. The first one is the degree of control you have over the business process. There are some business processes where you don't have a lot of control over. So for example, if you're trying to understand what your customer behavior is, there are ways you can influence it, but you don't have necessarily control over what any particular customer is going to do. Conversely, if I look at scheduling a plant or a factory, that's a process where you have a reasonably high degree of control. Now, you might have issues that come up in the factory where something runs off schedule, equipment can break down, but all that aside, for the most part, it's a process where you have a large amount of control, and that you often find within business operations. So optimization tends to lend itself to processes that have where the business has a higher degree of control. The second piece of this is the quantifiability of the business problem. Optimization lends itself well to problems that are reasonably quantifiable. Now, it doesn't necessarily have to be 100% quantifiable. There are ways to use scorecards or prioritizations to achieve good performance. And there's a large set of applications where that is the case. But there are other areas where, if you're talking about personal negotiations or, qualitative factors around an HR process, those are areas where you're going to find fewer uses of optimization, if any. So, as a rule of thumb, if a problem has a high degree of control and it's reasonably quantifiable, it's generally a good candidate for optimization. So now that we've talked a little bit about what a model is and where optimization can be used, we're going to talk a little bit about the value of optimization practice and the value that this approach brings versus other approaches. So the first thing I want to separate out is what we call big O optimization versus little o optimization, because the term optimization itself is used quite a bit in business. And one of the things that we find is important to do is to differentiate mathematical optimization from quote unquote process improvement or other types of algorithms. So, I think we've all probably been in a situation at some point where we sat down with somebody and they said, I optimized it. And what they mean by optimized is they sat down with a spreadsheet or a pencil and paper, and they found a solution which is better than their current solution today. And in my mind, that's what I would call little o optimization. Big O optimization is what I like to think of as the mixed integer programming approach to modeling a problem. Now, if we think about different solution approaches, the other thing that comes into play is how do you look at mixed integer programming versus other algorithmic approaches to solving a problem, such as heuristics. And when thinking about a problem, there's a couple things to keep in mind. One is, what's the level of abstraction you need on the problem? And that's what we have in this box on the right on the x-axis. And on the y-axis, we're going to talk a little about the solution approach. And the question is, where do you model? What level of detail do you model? And what's the right algorithm for doing this? And it's oftentimes useful not to get too hung up on all the exact details. Depends on the type of problem, but there are many where you can get by with some abstract level of detail, and even though you're not modeling every single nuance, the reality is you're going to end up in a much better situation One of the failure modes we often see for optimization is when somebody tries to have constraints in there for everything in the kitchen sink, and it ends up backfiring with the model. Now, there's different types of problems, and for different types of problems, you're going to want to do something different. If you're looking at something like a transportation model or a scheduling model, that's where you generally want to include a high level of detail. However, if you're looking at a network design model, that might be something where you might want to consider a more abstract approach. And the thing to realize is that you may lose some of the resolution on the ground, but you gain a lot more by being able to consider a more complex set of trade-offs, being able to run scenario analysis, and being able to look at shadow prices, and being able to add and remove constraints quickly. All those things are something that optimization lets you do. And when you're looking at heuristics, it can be very hard to do that. You know, if you have a problem which changes in nature and you have a heuristic built, very often you have to rework that entire heuristic to be able to come up with what you think is a good solution. But unlike optimization, with heuristics, you don't know how close you are to optimal. Of course, that's one of the benefits you get with optimization. The other thing I want to point out about optimization is it's often quicker and easier to develop than a heuristic approach. But one of the misconceptions is that this is a trade-off of either or. I can either build an optimization model or I can build a heuristic. And in the reality, these two things can be used quite effectively together. And in certain situations, there are benefits to being able to do this by building an optimization model, which can be the core of your algorithm, and then using a heuristic to clean up some of the edges around that in terms of the implementation. You know, one of the real benefits of this is that heuristics often don't react well as businesses change. So if I'm building a tool around a heuristic and I find a year or two down the road there's some unique constraint that I need to put in there, there's a real chance that you can end up having to rebuild the entire heuristic. With an optimization model, I could simply add a new constraint, and generally you're good to go. So one of the benefits of being able to look at these where I have an optimization model handling the dynamic piece of the business, and I have a heuristic around the outside, is that as the business changes, I could just quickly update the optimization model. The other nice piece about this is that because you have an optimization model doing a lot of the core computation, and you know that that optimization model is giving you a optimal or close to optimal solution depending on how you set up the model, you are generally given a superior result than using a heuristic alone. I'm now going to pass things off to my colleague, Colin Ketchinger.
So one of the things that has evolved over the past sort of 7 to 10 years is the ability to increasingly build your own. And what we're seeing is in more and more cases that option of building your own is now better than buying. Let me start by saying that's not certainly far from always true, and there's a good number of problems where commercial applications do an excellent job of solving the problem at hand. But what we are finding is in a number of cases there are increasing opportunities to do one of two things: directly build your own and stick with it, and the other is, quite frankly, is the opportunity to at least go through some evolution in your maturity, having built your own, reap the benefits of the learning, and then ultimately buy something as a much more educated consumer somewhere down the road. This chart has a lot on it. I'm going to start with the picture first and characterize its layout, and then we'll talk about some of the insights here. So on the left and right hand side, we have packaged software and custom tools, and underneath you'll notice, and they're flipped on the two sides, on the outside of the chart there is the perception, and on the inside two stacked bars we have the reality. And the height of each box is proportional notionally to the total effort involved. And where we've been for quite some time is, starting on the far left under packaged software and perception, is this notion that we've reaped the benefit of the development of efforts of a software organization, and our ability to procure a tool and get it up and running and merely configure it is a relatively small effort. And the good news is we'll spend most of our time doing the analysis. On the far right of this chart, under the perception of custom tools, there's a general sense that, hey, to build anything takes a tremendous amount of time, and then we'll still have the analysis piece somewhere at the end of it. And what we're seeing increasingly is, well, there is the reality of the packaged software where these projects often go overrun, and so we'll see a little more configuration effort than what we hoped. And we tend to spend much more time on the analysis piece than we ever thought we would. Similarly in the custom tools, the build effort is much closer in scope and size to the configure effort of the package software. And the return that we get for this is compressed time and resource requirements on the analysis. So we're going to do some more work up front, and we're going to do some things that allow us to get a fairly big return on the back end. And in a lot of cases, and certainly in the projects that we do, the analysis effort generally trumps the build effort. So now I'll go through some of the bullet points, starting with the bottom. There's these myths with off-the-shelf package software. Again, this does not apply to all vendors. There's a lot of great solutions out there for specific problems. But the things that even most of them would agree to is one solution can't solve every problem. It's why a lot of people do proof of concepts. It's why you run an RFP with multiple vendors, and then you ultimately pick one, and not everybody picks the same one for a variety of reasons. But the truth is, there are going to be cases where none of their preordained compilation of requirements truly matches what you're trying to do, and you have an opportunity to go and build something that may do that. One of the second myths is, with little training, anybody can use it. As you get through, and this doesn't just apply to optimization, but certainly advanced statistical techniques to do trade promotion management or forecasting, but certainly inventory optimization, network design, you go through all the classic analytics heavy problems. A good tool will help you do a lot of things a lot faster. It'll do wonderful things for workflow. It'll do wonderful things for disseminating decisions and making sure you have the right data. Ultimately, it's a poor substitute for the expertise of the user itself. So whether you're going to build or you're going to buy, don't count on your savings bucket when you're buying that 1 week of training is suddenly going to make someone an optimization expert. If anything, that's one of the biggest failure modes that we see. And then the last piece is it saves time. You know, it's the sort of the punchline of the chart above is that in some cases it does save time. In other cases, it certainly doesn't. And we've gone through a number of projects where, again, the reward we get for being able to cycle through the analysis at a much higher clip more than offsets any incremental effort that was in the build part. And of course, we don't always know for sure whether there was incremental effort or not on the build. We just know that the build is less than people's expectations. And of course, they didn't also buy necessarily. So it's not that we have a direct comparison. So what do we see when you build your own? Now moving to the text on the right. Well, one of the most important things is it solves just your problem. And the wonderful thing is when you build a solution that just solves your problem, there are no bells and whistles that solves anybody else's problem. And so you have a much simpler solution to work with, both in the design and the testing and the validation of it, but you start getting ancillary benefits, right? There's no unnecessary data gathering. Everything in that tool was put there for a purpose, and it's your purpose. There's no compromises on how you have to capture or fit things in. So we get to the second bullet point, which is they may ask for a field and they may ask it for a separate way. In the hands of a clever user, you might actually even get it to do what you want, but you're still fundamentally shoehorning a problem into a model that doesn't quite fit. So maybe you ended up selecting the package that was closest, but it's still going to require some clever workarounds. And so one of the rewards, both on the build side, but also on the analysis side is, again, you're not shoehorning a problem into a model that doesn't fit. The ease of use just went up considerably, and that's nice because you'll get something back in the buy-off from the stakeholders, and also just how quickly you can iterate through all the scenarios and inevitably are required as part of this type of analysis. What we're finding increasingly, if you have the right team and you've hired the right people, it's almost as fast to build as it takes to configure a package solution. So in a lot of our projects, I would say that no more than a third of the time is spent actually building the tool. We spend a lot of time, as you would for an off-the-shelf package, collecting, validating, refining data, making assumptions, testing assumptions, and then on the back end, as insights start to emerge, you realize that there becomes a very long list of scenarios that you'd like to analyze. And a lot of that time is both, running those scenarios, but also packaging, interpreting, and making presentations to the senior stakeholders. So the build is decreasingly important in the total cost picture as you think about rolling out these solutions. One of the nice things, and we'll come back to this in a little bit, that you realize these benefits, but stakeholders have a much higher chance of understanding the calculations and will buy into the results when you can sort of open up the hood, right? If you build it, you own the source code. Everything in there is a reflection of a decision that you made in terms of design. You can share it and validate it, and you can go and reconstruct it if it's not lining up as to where the stakeholders expect it to see. This ability to handcraft and mold the model goes a long way towards that stakeholder buy-in, as does the transparency, right? There's no black box, it's entirely open. And so what we're seeing in a lot of cases is we get better outputs and a more efficient analysis. And to the extent that there's any penalty because it takes you a little longer to build versus configuring, what you get in return, again, will justify the extra effort up front. One of the things that we're going to keep coming back to is the well-known black box syndrome that dooms many packaged software solutions, right? There's no shortage of analytics software that's out there that no longer gets used. At the beginning, Russell talked about we have a lot of customers who really can buy just about any solution they want, and they have, and they still come back wanting more. And the reason is either because of the pace of innovation. Big product software companies' product release schedules can't always keep up to the very specific things that they're doing. But in some cases, it's just a lack of trust in what the model's doing. And there's a very good long list of examples. Many successes again, but there are certainly areas where we've seen consistent failure modes. The other thing that we've realized is that good visualizations go a long way. And what you begin to understand is that a good visualization is in the eye of the beholder. And so whatever you do, you have to be able to get the data into a way that speaks personally to the key stakeholders. And we'll talk in the next slide about a process to get there, but these become very central tenets. And so if we were to summarize these, just continuing that point from the last slide, visual intuitive interfaces are absolutely key. And we work with a number of clients who are essentially number one and number two in the same industry. And in some cases, they even dominate most of that industry. In many cases, they even have senior management and directors all the way through the rank and file who used to work at the other company. So they're remarkably similar. And yet we find that in this new context, in this new setting, relative to where they are in the marketplace, they want to solve some of the problems very differently. The information and data they want presented to them are very different. Some of the levers that they have to pull in order to accomplish their business goals are even different. And so creating this customized experience becomes very important in the success of any sort of decision support framework. Right on the heels of that is this notion that the interaction with the math is as important as the math itself. If the users cannot line up and defend and support the recommendations coming out of the solution, there's a limit to how much they're going to be able to advocate for it or stand behind it and therefore continue to use it, right? There's just a whole set of decisions where if your boss says, well, why are we doing it? And you say, I don't know, the model told me to, generally your career growth is somewhat limited. And the last piece is what we find, and this is what naturally comes out of a build your own process, is that decision support is best developed in an iterative model. It's going to be customized to your business, not just the interfaces. You'll find that you'll have opportunities to solve your problem in a very specific way. So if you go to the old i2 JDA stack, they partialed out solutions in a way that worked for a lot of their customers, but not every one of their customers. And something that they decided was transportation planning may actually be blended with the inventory planning, but it's harder to get their modules together because they were designed more modularly. So there's a lot of reasons why you're going to get into this customization space. One of the big challenges, of course, is the software development was outside of the existing work done in your firm, right? Another firm built that model. And so there's a linear progression of requirements to build, to test, and deploy. Yeah, obviously there's new feature releases, and if you're big enough, you can sit on a forum with some of the big software vendors and participate in that process, but it's not nearly as organic as what we would hope to see for decision support systems. And what we're really looking for here is this cycle of mock-up, rapid prototypes, try out and learn, revise prototype, and just an evolving maturation process for the solution so that there's constant feedback, constant learning, minimizing the overcommitment to functionality that's not going to be needed in future, and a collective learning and a collective buy-in along the way, which goes a long way, again, towards that transparency and ultimate buy-in from the stakeholders.
So we've taken some time now to talk about a number of different issues. We've talked some about what the structure of a model is. We've talked about the uses of optimization. We've talked about the value of optimization versus heuristics. We've talked about the value of being able to develop your own system and how that compares to many off-the-shelf solutions. However, one of the things we haven't gotten into much is if we're looking at specific business problems, what are the values that optimization brings? So there's no silver bullet here. For each business problem, for each business case you're going to develop, the answer may be different. But there are some common threads that can often be found across a number of ones. So to illustrate this, we're going to go through a few business cases of problems that we've worked on with clients and talk about the value that we found in those activities. And then we'll look at how do we generalize that to other problems. So the first problem we want to discuss is a land auction problem. This is a combinatorial auction. This took place in Peru, and an investor had a number of lots of farmland, and they were selling off each lots in an auction. And a bid could come in where somebody could bid on a collection of lots. So somebody might come in, for example, as we have here in this top call out, they could bid on any 4 lots between A1 and A9. And the reason it's structured that way is there's value in having adjacent lots. Having one lot that's A1 and another lot that's in the bottom right hand, I think that's C8, is less valuable than having A1 and A2. Once you get all these bids, and you have these bids that are on all sorts of different groups of land, the problem is how do we go through and select this collection of bids that maximizes revenue? So again, this is called a combinatorial auction, and it's used in a number of places. For example, if you're a shipper and you're bidding on lanes, you want to make sure you get the backhaul. So the value of the lane from point A to point B and the value of the lane from point B to point A is less than the value of the lanes together. It's used in auctioning off radio frequencies, industrial procurement, and elsewhere. So when we talk about the difference between big O optimization and little o optimization, this is a great example to illustrate that. Now, suppose there's 100 bids that are put. There's 1.26 times 10 to the 30 combinations. So for somebody to sit down with a spreadsheet or a pencil and paper or whatever other tool you can imagine and try to figure out what the best solution is by hand, it's unlikely they're going to come up with it. If you were to have a supercomputer which evaluated 1 trillion combinations a second, it would take about 40 billion years to get through all these combinations. Versus if you structure the optimization engine, the optimization model right, you can do this in under 10 seconds. Now, there's really, I think, 2 key takeaways here. First is when talking about a model, one thing to mention is what's the number of decisions or the complexity of decisions that need to be made. I think oftentimes people underestimate the complexity of the business process because they're used to working in a particular way. And one easy way to get out of that is to look at the decision variables that you've created for your model. Remember, those are the levers that somebody can pull, and figure out based on the decision variables, what are the number of feasible solutions, and help people to understand the magnitude of that. The second thing here is the lesson about big O optimization versus little O optimization. This is something where if you build a model right, you can do it very quickly. If you want to do it by hand, you're probably not going to end up with an optimal solution. And just to give you a sense, when we did this problem, the way our contract was structured was once all the bids were in, they were going to take 24 hours to find a solution by hand, and we were going to run an optimization model. We were going to get a bonus based on how much better our optimization model did than the bids that they got in by hand. Once they got all the bids in and took a look at it, they just threw their hands up in the air and said, okay, guys, we're just going to pay the full bonus. Tell us what to do. So there's a lot of value that optimization could bring just in helping to solve the complex problems like this. The next example we want to talk about is this production and distribution planning problem. Now, it's also a very complex problem. I don't have the exact number of solutions that you would find here, but there are many, many there. So everything that we just said about that is true. But unlike the past problem where they threw their hands up in the air, this is a problem which is currently being worked on by 2 planners. The problem is to, 1, figure out what distribution looks like from the factories to the DCs, and then figure out a production schedule to support that distribution. So it's done sequentially by 2 different people, one focusing on distribution, one focusing on production. And you can imagine there's a large number of decisions that need to be made. Beyond that, there's a lot of coordination that has to happen between these 2 people for this to work out. And just naturally with the business processes, the people who own each piece have different incentives. So if I'm owning distribution, for me, it's going to be important to make sure that I have product available as many plants as possible. Versus if I'm owning manufacturing, I want the opposite. I want to produce product at as few plants as possible, because that's going to optimize my efficiency on the production side. Now, people are working together here, and through no ill will or animosity towards each other, they come up with a solution. The reality is, though, that solution tends to be biased one way or another. And as we often see when people implement process improvement projects for these types of situations, they tend to focus on one side or another. So they might have first project being focusing on the plant side, and then come back a few years later and say, now we're going to focus on the distribution network side. And you get a pendulum which constantly swings back and forth. One of the real values of an optimization model is it can balance these competing priorities and get you to that optimal answer without having this constant back and forth. And as the situation changes, you can always update the model. Now, beyond that, what we have here are two people who are working full-time to create these plans. So one of the other values that optimization can bring is it really changes the nature of that work, right? Because no longer do I need to think about just how do I create a plan to survive. Now I can think about, what if I do scenario analysis? What if I do things differently? What if my costs change? What if I want to invest in some capital equipment that's going to improve efficiency or improve distribution? So optimization here brings a number of different qualities, right? One is you're again coordinating conflicting objectives, and you're really changing that role of a planner from a tactical position to having a big strategic component, which means you're going to get a lot more out of their time. The last problem we want to talk about is a scheduling problem in the retail space. This problem is with a retailer in Latin America, and what they're working on is trying to figure out how many people should I have on the floor for any particular shift. So if you look at the graph below, they had the orange line, which is what their current state is and how they staff their stores. And they said, okay, well, let's look at some things. What if we look at the volume, how that differentiates either in different times of day, the different times of the week, and holidays affected. And the reality, if I consider that, I don't really need that regular staffing schedule. I can cut way back on my staff and still effectively serve my customers. Well, that in itself is somewhat of a challenge because there's various labor laws and other things that are in play that affect the way you can do that. But if you have an optimization model, you can oftentimes build those things into the model and get a solution like this. So the other thing to realize is when you're looking at a scheduling problem like this, very often there's ancillary benefits beyond simply the value of the optimization. And you can consider things in there that are much more difficult to consider for a person who's doing the planning. For example, we've worked with a number of union production environments. We have contracts that may do something like if somebody comes in to work for a week, there then benefits for a certain number of weeks after that. So there's this implicit cost of having a spiky schedule, because if you bring somebody in for a week because you need some surge capacity, you now have this ongoing cost to pay for that person. Again, one of those things which is harder to consider by hand, but you can build into the optimization model. Another thing to think about is there are areas of the world where labor is very tightly controlled and you can't cut back on labor, but there are issues around quality of life and just coming up with a feasible schedule. That's another area where optimization can play a role, because you can very often benefits for things like quality of life, things like consistency, things like resiliency, which you're never going to explicitly cost out in the model, but it is a benefit to the business. Now, I want to talk more about what does it mean to build a business case beyond simply looking at cost savings. One of the challenges with using cost is that cost savings can often be very hard to quantify upfront. Oftentimes, what we try to do is figure out how do we work with the business to get to a proof of concept to understand what the size of the pie is. And there are certain cases where you can do some back of the envelope calculations to understand what the cost savings might be, but very often that's quite hard to do. So learning from these examples we just went through, what we want to do is come up with some key arguments, again, that you can use within your own organizations to hopefully progress the conversation and get to the point where you can get to that proof of concept or start to build the model. So in both the second and third example, one of the things to keep in mind is how we change the role of the planner. And it's very important to think about not just what optimization is doing, but how it fits into the planning process. You know, there's many scheduling applications where the problem is not always creating the first schedule, it's recreating the schedule when something goes wrong. Being able to have a tool which quickly helps you get back to normal is something where you're not always going to necessarily be able to capture in the costs up front, but it's something which is quite valuable. I find very often you find these people spending most of their time recreating a schedule. By removing that aspect of their job where now they can rely on an optimization engine to do that busy work, it really lets them focus that time on other value-added activities. And part of that is figuring out what's the right way to implement optimization, because there's sort of a range of options out there that we can use. You know, oftentimes I think people think about this as full automation. I'm going to put an optimization model in place, I'm going to click go, it's going to give me an answer, and I'm set. And you know, there are times that works, but often that's something that's aspirational, and oftentimes that's not the right value for the business. Sometimes it might be too big of a step, and sometimes there are all qualitative factors that need to come into play before the final decisions that can be made. And to be able to consider that, you can do a number of things. You can optimize around a solution, right? They can put into place things that they don't want to change. You could take that as constraints in your model and figure out the rest. Or you could look at creating an initial plan of optimization and letting them use that as the basis for their solution. So you know they're at least starting from a good point rather than starting from scratch. So one of the things to be very critical of, or to think critically about when you're doing this, is what's the right way to employ this optimization model? As I mentioned, in almost every optimization model we see, there's some notion of balancing competing priorities, right? You have different costs in the objective function. Very often those things are, if not orthogonal, somewhat close to orthogonal from each other. The idea is, how do we figure out how to balance these that's in a way that's best for the business? And we found this is also a very good argument to use with clients, and it's one of the ones that we've had a lot of traction getting buy-in with. So in summary, you know, if we're thinking about optimization, you know, cost savings or revenue maximization, whatever the objective function might be, that is a big piece of it. I don't want to discount that. But there are other pieces of optimization, a lot of the ancillary benefits, which I think are what make it a powerful solution for a lot of business problems. You can automate a lot of the busy work, right? You can take planner roles that are often tactical and make them more strategic, which provides a lot more value to the business. You can work on balancing competing priorities, right? It often provides you increased flexibility over other approaches like heuristics or software. And you can align the model to your business in a way that makes sense.
So the title of this slide is where we can help, but it's also a good way of framing of, you know, where you can get started and an approach for both making sure we're solving the right problem, choosing the right solution, and ultimately successfully influencing a decision at the end of the process. So I thought it'd be helpful to walk through briefly just this flow that we go through. And certainly, as the title suggests, these are all things that we can help with. For us, it always starts with a qualitative description of the business problem. The opportunity here is to get everybody to agree in English, what is it we're trying to accomplish, what levers are we going to pull, what are the value opportunities that we think exist, and what problems are we going to solve. We should then immediately after that be able to identify the principal metrics. So if we describe the problem, we should certainly understand what metrics we're going to be able to influence, and this begins the process of quantifying the remainder of the problem. Another key distinction in this is to understand how the math will support the decision-making process. We're going to find ourselves in instances where we have true decision support, where the analytics will put forth recommendations and facilitate a discussion and get to an answer, and we'll talk about that shortly. We'll have other cases where we expect the math to make the decision and with a very, very high likelihood make the decision on its own correctly almost all the time. Once we get through that, we're now ready to formulate the math problem and move on to choosing the solution. It is a big question as to fit. What will actually solve the problem? Sometimes it is a simple spreadsheet in which you just enumerate all the possibilities because there are about 7. And in other cases, as in with the land auction, there's literally billions of considerations or possibilities, and there's no way that anything other than a solver will be able to generate a solution. And of course, there's a lot of things in between. One way of parsing this out is starting with this notion of, do I have a strategic problem or a tactical problem? In general, the more strategic questions, you're going to go through a process of simplified inputs. You're going to evaluate lots and lots of scenarios, and a big portion of what we're trying to accomplish is the why, not just the what. When this is done well, the decision makers are left with a challenge of their long-held assumptions, a deeper understanding of the underlying mechanics, and the ability to integrate the learnings into their management judgment so that every time they need to do something, we're not back to necessarily running the model. On the flip side, there's a long list of tactical problems. What we are very interested in here is live input data. So this is one of the reasons we see successful for commercial off-the-shelf solutions is they've already gone through all the integration and things like that. This can be a little harder as you build your own. There's going to be a little bit more work here than you anticipate. But as you get into these technical worlds, you almost certainly, for speed of execution, need to work with live input data. We're beyond the point of doing a lot of scenarios. There may be, oops, a supply line went down, what should I do type scenarios. But for the most part, for a lot of the decisions, speed is of the essence. And therefore, you're not at the luxury of running scenarios. You're employed optimization to solve the problem as quickly as possible. And along those lines, the what is now much more important than the why. Right? We need a recommendation, what freight lane to use, put it on, get the product moving and get it there on time. Why it was the optimal freight lane, that's not something that you're going to do in the midst of executing a high-speed process. The last piece then is being able to frame the decision. Make sure we've taken what we've learned about the qualitative description of the business problem and the metrics and start to build the case that as recommendations come out of the engine, that they are in fact the right decision. And there's 3 main things that we can do here. One is compare the optimal solution versus the most robust solutions. So a good opportunity for a class of problems is, as you go through your scenario analysis, the winner may be different in every single scenario. And you're left with the question of, all right, there's a lot of nervousness, what do I do? If you've built this well, you can identify what the second, third, or fourth best solution also was. And then you have an opportunity to see if any solution regularly shows up in the top 2, 3, 4. And even though it may never be optimal, if it's consistently near the top, there's going to be a lot more comfort in adopting those recommendations than finding the optimal that absolutely fits each scenario. And that's sort of the optimization version of overfitting when you're doing forecast and regression analysis. The second piece is communicating the whys. If we're going to adopt a solution or integrate optimization into our process, while we're running the process, we don't necessarily need to communicate the whys, but certainly to have a process adopted, or if it's just a why-type problem in general, we have to be able to communicate those whys. This deeper understanding, this trust, this confidence, this transparency, again, are going to be essential. And then the third thing is you sort of wear your hat on how are we going to get people to sign up to this. Not everything can be converted to the same unit of measure. There are things I can dollarize, and in theory I can dollarize everything, but at times it feels contrived and forced. And I just have a little example here at the bottom, this sort of return on invested capital versus TAT trade-off. So that's the smaller of the 2 titles. But what we're really comparing is a capital investment versus customer service. And TAT, which is on the horizontal axis, is measured in days and stands for turnaround time. How quickly will I get a product to my customer? The vertical axis is return on invested capital. And really what we've decided not to do in this case was try and dollarize what 1 day of response time would equal. Rather, we've presented to the users, hey, we can dial the model up to favor one attribute more than the other and give you a spectrum of solutions. Think of it as an efficient frontier. And now it's in the hands of the senior management to decide, all right, how would I like to trade off a day's worth of response time versus that return on invested capital? So that's what we mean when we're trying to bring forth the complex trade-offs and drawing an appropriate line of getting a math through some contrived dollarization of turnaround time, which is going to be abstract and hard to understand, into a simpler framework, which are units of measures that they can intuitively respond to and exercise their judgment against. So quick closing thoughts. We're all very quantitatively oriented. That's generally why we live in the land of optimization, and probably why you sought out both Gurobi and or people like us and attended webinars like these. It's very important to understand the qualitative benefits that optimization can bring to your job. We have a good friend in the business, and he keeps coming back to the notion that it's almost a given that you're going to figure out a way to save money. But the real key to adoption is, does it make someone's life easier? You're down to the individual users whose job are going to be affected by the optimization that you're going to introduce. There's going to be resistance for a lot of reasons. One, a fear of them losing their job, but even the other fear, where it's clearly they'll keep their job, but you're now landing some tools on their desk that they haven't been trained in. And does it marginalize their contribution, or do they start to look bad because they don't really understand what's going on? And so it's important to cross both of those bridges. Demonstrate that it's going to make your life easier, and get them really comfortable so that they can represent as an expert user. That's the first level of stakeholders that we get on board, but obviously we keep coming back to the senior management that's going to need to approve this and actually execute on the decisions that will demonstrate the value that you're trying to create. We've come back to this notion of transparency over and over again. It's absolutely important to get that transparency and go through the entire list of stakeholders, not just the most senior management, but everyone down to the users, because they all have an ability to make this project successful or not. And then, the last piece is project planning. What we want to ensure is that as we roll out opportunities and benefits, they sort of align with the needs that they're facing at the right time. In a lot of cases, if you go through the discipline of formulating an optimization problem and cleaning up the data, organizing the data, and managing the data such that you can run it, I can guarantee you that the users will say, just the delivery of the data, even if I never hit the optimization button, you've already delivered significant value. And through the formulation process, you've helped us align on some of our priorities. It's a wonderful thing to do, to be able to deliver that value before you get through the next part of actually coding the optimization and delivering it. And this is a good example of being able to address the immediate needs that your users are going to have, with the promise of even greater value down the path. And then lastly, look, if there's anything we said, you have more questions, we're not going to be able to answer all of them today, feel free to contact us. We promise not to charge every time you talk. We're not lawyers. We're members of a community. Our mission is to drive the adoption of analytics. If we do nothing other than an hour, hour and a half, 2 hours of an exchange of ideas, we've walked away with something valuable, which is a greater appreciation for how people are doing this. Hopefully we've left you with a few nuggets, and we're happy to see where it goes from there.